Hello, my name is Evelyn. Welcome to the Autonomous Machines World 2019. I'm here with Shreyansh. Shreyansh, thank you for joining us. Could you please introduce yourself and your background and let us know what you do?
Thank you for having me here. It's great to be at the conference. My name is Shreyansh Daftry. I'm a robotic technologist at NASA's Propulsion Lab in Pasadena, California. My background, I was born and brought up in Kolkata, India. I did my bachelor's in electrical engineering from India. Then I moved to the US where I did a master's in robotics at Carnegie Mellon University before joining JPL. I have been at JPL for 3 years now, and my role there is basically to help develop the next generation of intelligent robots for Earth, Mars, and beyond.
Okay, great. Your session will be actually talking about developing artificial intelligence for robots in Mars, Earth, and beyond. Could you please tell us more about your session?
Right. So, JPL and NASA, one of the main charters that we have is to help develop robots that can go explore the different parts of our solar system and look for and do different scientific experiments. At the same time, we also develop robots that work here on Earth, and both for the US government as well as different commercial applications and research in general. So we have this huge portfolio of robots that we build, and as we grow, get into more complex missions, we need to develop robots that are intelligent and more autonomous in their behavior and can do decision making on their own. And this is my role. My role is basically to develop those algorithms that basically act as the brain of the robot and help them think on their own and see, perceive, and make decisions.
So, what are the challenges that you've encountered as you are developing these robots for Earth, Mars, and beyond?
So, some of the challenges are that we have developed, especially in my role of infusing a lot of the very new cutting-edge artificial intelligence technologies into building complex systems, are how to develop algorithms that are scalable, that can be put into flight safely. Safety is a very big factor in making sure that we can ensure that these systems can be deployed, because still we cannot guarantee that these algorithms we write can allow the robots to safely make decisions. We cannot really put them into flight, which is basically deploying these missions. So how do you take these artificial intelligence algorithms that's developed theoretically at universities and then transform them into a robust, scalable system that can be actually being deployed on a different planet? The stakes are pretty high there. So enabling a one-shot success with no failure, no acceptance of failure at all, is the challenging part. Okay. At the same time, space itself brings a lot of challenges which are not typically expected on Earth applications. Like, for example, how do you deal with radiation? How do you deal with short amounts of data, especially when you're doing things like machine learning? How do you work with environments that you've never been to? How do you account for all possible situations that you don't even know about? And developing intelligent algorithms for robots to do that is really hard, and that's the challenging part, which also makes it fun.
Yeah. Oh, that's amazing. What solution could you tell us about one solution that you have used to tackle the challenges that you're going through right now?
So one of the solutions that at least we learn in the way to include machine learning or these black box systems is trying to look at the whole system perspective and trying to do exhaustive testing in different kinds of situations. So, for example, if we want to send a rover to Mars and we want to develop algorithms for that, on Earth we create as Mars-like environments as much as possible. One of the examples is JPL has Mars Yard that we've created that basically is a small area that emulates environments similar to what we would expect on Mars. So for anything that we want to deploy on Mars, we first try to test the heck out of it here on Earth. We envision all possible scenarios that could go wrong to the extent we can, and then we try to make sure our system works to that and probably a bit beyond that, to make sure that when we actually go to Mars, it knows what to expect.
Okay, that's really good. Is there anything else you'd like to tell us about your involvement with your project?
I think it's been a great learning curve,
Yeah.
working with my projects and working with at JPL, because it's really coming from an academic background. It's allowed me to look into how to develop how to take algorithms and basic research and transform them into real world systems that actually work. So thinking from the perspective of the end user,
Okay.
as well as trying to innovate and
Yeah.
how to bridge that gap, is something that's really fun.
Oh, that's good. Well, this is my last question actually. What are your expectations and what are you looking forward to?
I'm really excited to be here at the Autonomous Machines event. I think it's a very unique event, at least from me, because I'm typically accustomed to going to more academic conferences, and having a lot of folks from the industry here allows me to really get the different perspectives from what the decision makers and the influencers think about technologies, helping educate them, market what the work we do and how that forms synergies into the industrial setting. I think this is a great venue that allows me to do that. So I'm really enjoying that so far and hope to do that in the next couple of days.
Oh, thank you so much for joining us, and I hope you enjoy the event.
Thank you so much for having me. It was a great experience.
Oh, great.